We're looking at homework from section 5.4. This is question number 8. For the following situation, find the mean and standard deviation of the population. List all samples with replacement of the given size from that population and find the mean of each. Find the mean and standard deviation of the sampling distribution and compare them with the mean and standard deviation of the population. The scores of 3 students in a study group on a test are 95, 94, and 90. Use a sample of size 3. So to find the mean, we're going to add these values together, 95 plus 94 plus 90, and that gives us 279. Once we have that sum, we need to divide it by the total number of values we were looking at, which was 3. So the mu is 279 over 3, which is 93. That's our mean value. For the standard deviation, I'm going to set up a little table. We're going to take our x values, then subtract the mean from those, and then square those values. So our x values are 95, 94, and 90. We subtract the mean of 93, and 95 minus 93 is 2, 94 minus 93 is 1, 90 minus 93 is negative 3. We square the values in the central column. 2 squared is 4, 1 squared is 1, negative 3 squared is 9. To find the standard deviation, we use this formula. Sigma is equal to the square root of the sum of x minus mu squareds divided by n. That means we take the sum of the last column and we divide it by n. So 4 plus 1 plus 9 is 14, and the n value here is 3. It's how many data entries we had from the population. So this is going to be the square root of 14 divided by 3, which as a decimal is 2.160246899. Rounded to 2 decimal places is 2.16. That's your standard deviation. So let's look at the next part. Identify all samples of size 3 with the correct accompanying means below. So this looks like a lot. Since these samples are taken with a replacement, repeats are allowed. So there's 3 possibilities for the first value you choose, 3 possibilities for the second value you choose, 3 possibilities for the third value you choose. So according to the fundamental counting principle, there's 3 times 3 times 3, which is 27 possible samples of size 3 here with replacement. Well, if we look up here on this table, that seems like a lot of values. Guess what? It's 27. They give you 27 samples of size 3. So our choice here is going to be all of these values because we have these 27 samples. And the way that I've listed them here, these are the 9 samples that begin with 90 as the first value. These are the 9 samples that begin with 94. And then these are the 9 samples that begin with 95. Once you have those, you can find their means by adding the 3 numbers together and dividing by 3. And all of those sample means are correct. So what do I click? I click everything because all 27 of those are the values that we're looking for. So let's move on to the next part. The mean of the sampling distribution is, and the standard deviation of the sampling distribution is. Now, you might remember in our notes, we did a problem like this, where we had numbers on slips of papers, and we had a population that was size 5. And we did this, and we went through a large process to find all the different means, and then use those as a sampling distribution values, and come up with the mean and the sampling distribution there. Here, for the sake of brevity, we're just going to use the formulas. And the formulas that we have are that mu of x bar is equal to mu. So for us, the mu was 93, so mu of x bar is going to be 93. And for sigma of x bar is sigma divided by the square root of n. So that makes it the square root of 14 over 3 divided by the square root of 3. Why didn't I just use the 2.16 as the square root of 14 over 3? And the reason is because that's a less accurate value. So if I do this, I have the most accurate value I can possibly have, square root of 14 over 3 divided by the square root of 3, which in your calculator gives you 1.247219,129, rounded to 2 decimal places, is 1.25. And that's your sigma of x bar. So let's look at the final part of this question. Choose the correct comparison of the population and sampling distribution below. So these comparisons are comparing the means and the standard deviations. So let's go ahead and review the answers we got from earlier in the problem. Mu was equal to 93. Mu of x bar was equal to 93. So the means are equal. Sigma was 2.16, and sigma of x bar was 1.25. So the standard deviation of the sampling distribution of sample means was smaller. So when we look at these choices, the correct choice here is answer B. The means are equal, but the standard deviation of the sampling distribution, sigma of x bar, is smaller. That's your answer.